A thin uniform rod of length 1 meter and mass 1 kg is rotating about an axis through its center and perpendicular to its length. Calculate the moment of inertia and radius of gyration of the rod about an axis perpendicular to its length through a point midway between the center and its edge.
Hello friends, problem आपण वाचलेला आहे आणि प्रॉब्लेम मध्ये there is a thin uniform rod AB. The length of the thin uniform rod L is 1 meter and the mass of the same rod is 1 kg. Now, they have asked us to find the moment of inertia I at a point which is passing midway between the center C and one edge, supposing A. So, P हा पॉइंट A आणि C चा सेंटर आहे आणि या P या पॉइंट मधून जेव्हा ऍक्सिस ऑफ रोटेशन पास होते आहे त्यावेळेला हा रॉड जेव्हा असा अबाउट दिस ऍक्सिस ऑफ रोटेशन तो रॉड असा रोटेट होत जाणार आहे. व्हॉट इज द मोमेंट ऑफ इनर्शिया अबाउट an axis passing through point P? हा फर्स्ट पार्ट आहे आणि
सेकंड पार्ट आहे व्हॉट इज द रेडियस ऑफ गायरेशन
of the same rod. Now, we know that since this is a rod and when the axis of rotation passes through point C, which is the center of mass of the rod, which is a transverse axis passing through the center of mass, then the moment of inertia, as we have studied before, is given by ICM, that is moment of inertia about center of mass, is ml square upon 12. Now, we want moment of inertia about this axis which is passing through point P. So, since these two axes of rotation are parallel to each other, hence we discuss about, we consider the theorem of parallel axis. So what is the theorem of parallel axis? I is equal to ICM plus mx square. Moment of inertia about any axis of rotation is the sum of moment of inertia of the same body about a parallel axis passing through the center of mass plus the whole mass of the body and the square of the distance between the two parallel axes. So, ICM आपल्याला माहिती moment of inertia about this axis, about the center of mass. It is ml square upon 12. So आपण ml square upon 12 लिहून घेतलेला आहे. Next, m is the mass of the thin uniform rod and h is the perpendicular distance between the two parallel axes. Now, distance between A and C is L by 2. Hence, distance between P and C will be L by 4. So, the L by 4 is the distance. Hence, the h is L by 4. So, we take here L by 4 square. So, ml square upon 12 plus ml square upon 16. Taking the LCM, which is 48, we get here I equal to 4 ml square. This 4 will go up, this also. And we get 4 ml square plus 3 ml square upon 48. 48 is the LCM. I equal to 7 ml square upon 48. But putting the value of m and l, we get 7 upon 48 is the value of I, which we calculated as I is equal to 0.1458 kg square is the moment of inertia about this axis of rotation when this rod is rotating in this way about this axis of rotation. Next, they have asked us to find the radius of gyration about this point P. Now we know the formula for radius of gyration, which is I is equal to mk square, where k is the radius of gyration of the body about that axis of rotation. Now we know that the moment of inertia here of this thin uniform rod about the axis passing through point P is I 7 ml square upon 48. So we write here I equal to mk square is 7 upon 48 ml square. Now from here m we cancel, so we get k square is equal to 7 upon 48 L square. So taking the square root, so k is equal to under root of 7 upon 48 L. So k is equal to under root of 7 upon 48, the value of L is 1. So finding the square root, we get k equal to 0.3818 meter.
A ballet dancer spins about a vertical axis at 90 rotation per minute with arms outstretched. With arms folded, the moment of inertia about the same axis of rotation changes to 75% of its initial moment of inertia. Calculate the new speed of rotation.
Problem is about a ballet dancer and she is spinning, and with 90 rotation per minute she is spinning with arms outstretched. तिचे हात कसे आहेत आता आर्म्स आउटस्ट्रेच केलेले आहेत आणि त्यावेळेला ती स्वतः भोवती गिरक्या घेते, ती स्पिन करते. कशी 90 रोटेशन्स इन 1 मिनिट ती घेते. नाउ लेट I1 be the moment of inertia when she is spinning with 90 rotation per minute. Now we know that rotation per minute is no SI unit. आपल्याला SI युनिट मध्ये म्हणजे हर्ट्स, रोटेशन पर सेकंड, म्हणून आपण इथे लिहिलं 90/60 रोटेशन पर सेकंड. सो 9/6, so we get 3.2 hertz is the frequency of the rotation of the ballet dancer initially when I1 is the moment of inertia. मग त्यांनी काय म्हटलेलं, नाव दॅट बॅलेट डान्सर द आर्म्स, शी फोल्ड्स द आर्म्स. आता तिने हात तिचे फोल्ड केलेले आहेत, म्हणजे मोमेंट ऑफ इनर्शिया आता काय झालेला आहे, डिक्रीज झालेला आहे. आणि तो किती डिक्रीज झालेला आहे, तर आता न्यू मोमेंट ऑफ इनर्शिया हा पूर्वीच्या मोमेंट ऑफ इनर्शियाच्या इट इज 75%. सो वी राईट I2 इज 75% ऑफ I1. दॅट इज 75/100 ऑफ I1. दॅट इज 3/4 I1 इज द न्यू मोमेंट ऑफ इनर्शिया I2. Now, we have been asked what is the new frequency of rotation and what is the new speed of rotation of the ballet dancer. So, we go for the law of conservation of angular momentum. What is the law? I1 omega 1 is equal to I2 omega 2. That is the angular momentum I omega always remains constant. If we increase the moment of inertia, the angular velocity omega decreases and vice versa. So I1 omega 1 equal to I2 omega 2. Omega 1 च्या जागी आपण लिहिलं 2 pi f1 आणि omega 2 च्या जागी लिहिलं 2 pi f2. So cancelling this 2 pi we get I1 f1 is equal to I2 f2. Now I1 f1 is what? 3/2. I2 is 3/4 I1 and f2 is the new frequency of revolution of the ballet dancer. Now, we cancel I1 also, so we get F2 is 3/2 is equal to 3/4 F2. So, F2 is equal to 3/2 into 4/3, that is 4/2. So, F2 is 2 hertz. म्हणजे आता ती किती फ्रिक्वेन्सीनी रोटेट होते आहे? 2 hertz. That is 2 rotation in 1 second. So, how many rotation in 1 minute? So, 2 into 60, that is 120 rotation in 1 minute she is rotating. So this is the new frequency of rotation. पण आपल्याला आन्सर मध्ये त्यांनी काय विचारलेलं आहे, इथपर्यंत जर फक्त फ्रिक्वेन्सी ऑफ रोटेशन इफ दे वुड हॅव आस्क्ड देन वी हॅव गॉट द आन्सर, बट दे हॅव नॉट आस्क्ड द फ्रिक्वेन्सी ऑफ रोटेशन, दे हॅव आस्क्ड अस द न्यू स्पीड ऑफ रोटेशन, that is the angular velocity. So omega 2 is 2 pi f2. So that is 2 into 3.142 into 2, that is 12.568 radians per second. म्हणजे आता त्याची अँग्युलर व्हेलॉसिटी त्या बॅलेट डान्सरची किती आहे, 12.568 radians per second. So this is the new frequency and the new angular velocity. Thank you.